Hello friends, today I am presenting here the recommender system. It is a part of your 6th unit. In this recommender system, we'll focus on 2 points. Very first is content based systems and another is the model based collaborative filtering. Now let's come towards the first slide. So here we have the recommendation system. So the question is what exactly the recommendation system is. So here the recommendation system is defined as it is a kind of system which gives you the more relevant information to the user by finding more similar pattern of available information. So here there is an interaction between the users and items, and whenever user wants to purchase an item, then a set of items gets suggested to it so that user can easily get what he want to buy. The basic examples of this recommender system is whenever you visit a Flipkart, then you can find a set of items are recommended to you. Now the question is arises that how these items are coming into your recommendation list. So for that sake, a set of algorithms are used that we will see afterwards. Another example here is a moving streaming sites which recommends a set of movies to you. So this is again one kind of a recommender system. Now let's move towards the next slide. So here we have the recommendation system. It basically categorized into two parts. Very first one is the content based filtering and another one is collaborative filtering. Content based filtering is also called as the user base. Now let us have the content based filtering. So in the content based filtering, the main preference is going to given a similar type of items. For example, here the books of the same author, the songs of the same genre, etc. So here we can see that the recommendation is directly related with the item. So whenever a user wants to buy a certain items, then from a set of list, it will get recommended to the item which user wants to buy. Now it can be modeled with this set. So here we have the item list I. So it is from I1 to IN. So each items consist of the several you can say elements, and each items consist of several of its features based on what the item gets evaluated. In this specifically content-based filtering, a clustering strategy such as k nearest neighbor to find a control size of neighbors to find a suggested product. So here the similar type of items are clustered into one, and based on the ask item it gets compared it with, and depends on the similarity measures the item is recommended to the user. To get the nearest item or to find the similarity of the items, a distance matrix can be used over there. There are the several distance metrics such as Manhattan distance, jacket distance. There can be also a k nearest neighbor method which can also be how to group the items together. In this diagram, you can view that the user initially buys certain items, and then the similar type of item gets presented over there. Suppose a user uh, read a specific book of a certain author, then whenever the user wants to read the another book, at that moment, what gets happen? The user previously read a book of a certain author, then a certain set of books of the same author get recommended to the user so that he can easily find the book he want to read out. Now let's move towards the next, which is the collaborative filtering. It is somewhat different. It is based on the collaboration. So collaboration gets occurred with the users. In this recommendation system, there are the two sets of elements. Very first is the user and another one is the item. So from the diagram, it is clear that a group of user is there, and a group of users are giving their ratings to a certain set of items. So those set of users are interested on a certain set of items, and the user who, to whom the recommendation has been made, that again comes under that group. And then the recommender items from those set of groups are given to the recommendation of that user. So here what happens, we are collaborating the item sets of a specific group of users. That's why it is called as the collaborative filtering. The model uses a user item matrix to have this model. So in this one, the user item matrix is there, and in this matrix, the rows are corresponding to the user and the columns are corresponding to the items, and each user is giving a certain rating to a certain item. Here we can take a very simple example about the movies. So a set of movies, there are the different movies which is rated by a user. So rating is given in terms of 1, 2, 3, 4, 5, etc. Suppose the 5 ratings are given, and if for a certain movie, if the user has not rated, then it has to be put 0 over there. So in this way, this rating matrix is built over here. Now, the collaborative filterings are again of two types. So very first type is the memory based and another one is the model based. Now let comes to the first, that is the memory based. So in the memory based collaborative filtering, it is also called as the model free, because here we are not directly related with the uh, model, specific model. So it can be represented in terms of user and the item matrix. So in this user and item matrix, we have the rows as the users and column as the items, and their ratings are represented for each row and columns. Now here we can have the rating given for every item is from 1 to 5. If the user has not given the rating, mean it has set to 0. Now here what gets happened, the users are clustered based on the ratings. So here the group of user gets formulated over there based on the ratings only. So in this one there has one drawback, which is nothing but a cold startup, where whenever a new user come into picture, at that moment it doesn't have any rate to any item. So at that moment the difficulty gets occurred over there. Now whenever similar we have formulated a similar user group over there, for which a cluster has been made. So we have to build a cluster for the similar users from this matrix. Now the product having higher ratings for the users are likely to be bought. Now whenever user wants to purchase or wants certain item, at that moment the product which having the higher ratings are suggested to user, so that user can buy it. So for that sake, Grab is a one open source framework which is used to build such memory based collaborative filter. Now let's move towards the another kind of collaborative filtering, which is the model based. It is somewhat different than the memory based. Again, the same kind of picture is there, that is user item matrix. So in this user item matrix, it consists of a certain latent factors. Now the question arises, what the exactly this latent factor is. So latent factor is nothing but a set of measures or the set of values which are not included in the item matrix. Uh, Whenever you want to take what exactly this latent factor is, suppose you have the user item matrix over there. Suppose user has a rate to a movie, certain movie, suppose at that moment, on what basis the user has giving a kind of rating to that movie, that is not clear. So there are the certain set of parameters which are over there. So based on that, the user has given a certain rating to that. But in that matrix, that elements are not considered. So such kind of unavailable values are called as the latent factor. So here, the again we are considering the two things. Very first is the generic user. So it is represented by the pi. So here it gives as a set of pi1, pi2 up to pik. So k is corresponding to the k latent factors. So it has a top k latent factors which has to be considered over there. A set of n latent factors are there, and from all those n, top k has considered, and those are included for user as well as item. That's why this uh, variable is considered over there. So similar for user pi and the item qj. Now here the ranking gets obtained from this pi and qj. So ranking is calculated equal to pi bar into qj transpose bar. So in this way the ranking gets identified. Now here the latent factor, here we have to consider what exactly this latent factor, the value of the vector component which are not known, which we just discussed now. The k latent variables are assumed over here, and here the main question is what should be a correct value of k. So how much latent factors, latent variables you are considering over there. So the main challenge over here is to get these latent factors. So for that sake, we have again two methods to find such latent factors. So with latent factors of the latent variable. So those are the singular value decomposition method, and another one is the alternating least square strategy. So we'll see very first the singular value matrix, singular value decomposition method. So under this again we have to consider a user item matrix, and uh, that gets considered over through a low rank factorization, and it can be given with suppose the matrix M is considered over there, which is over user and items. It can be decomposed into the three factors. So very first one is the U, another one is sigma, and V transpose the another one. So here U and V are the unitary matrix, and sigma is the diagonal matrix. So U is the left singular, and the transpose of V is a right singular matrix, and the sigma is a singular matrix. Now in this way, for the k factors we have k singular values here. Now the nk, the matrix is represented in this manner. Now whenever we are applying this singular value decomposition over the matrix, then we are getting all these three different variables over there, that is the u, sigma and v. Now this in this way the two latent factors are identified from this. So very first latent factor is SU, that is for the user, latent factor for the user, and another is latent factor for the items. Latent factor for the user is represented with this, that is the UK into square root of sigma k transpose. Similarly for the input items, for the items we have the square root of sigma k into vk transpose. Now the resultant prediction for the user I and item j is calculated with this formula over there. So the formula is the Rij equal to E of Ri plus Su of I into Si of j. Here the term is new here, so it is nothing but the average of the item or the mean value of the item for a specific user I. So in this way the singular value decomposition method is used for the rating prediction for a certain user for an item j. In this manner the singular value decomposition method is used to identify the latent variables, and from that one the rating has been calculated, target rating has been calculated. Now there is one more method, that is the alternating least square strategy. In this one, latent factor calculated with the least square optimization on the problem with the loss function, and that loss function is represented here. So in this equation we have this um, loss function. So we already have all the terms which previously defined. Only one new term is exist over there. That is the alpha of pi square and plus qj square. So it is called as the regularizer factors. And the main target here is to minimize this regularizer factor so that the loss also gets minimum over there. So here L should be a minimum to get user items, and the two steps are followed here to uh, get the minimized value of this L. So in the algorithm, very first the pi is kept constant and qj gets optimized with this pi. Another is the qj is fixed and then pi is optimized, and the algorithms is iterate both of these steps till the precision is received. The precision means the least loss which are not further get degraded. So in this way, we have used the least square strategy to get the ranking. So in this way, I have covered the recommendation system where the least square strategy and another one is the SVD is used. Okay, thank you friends.